Right. Oh, of course, everything fails now. Right at this point, right? What's happened? Hang on. Where's Discord gone? Is that there? We go. Oh, I see. Right. If I minimise that, then okay. Right. It's just still working this out, everyone. Look, I haven't done this before, but we've got a smiling blueberry, so we're all good. Can you say hello when we get a sound check?
Hello, everybody.
Yes, it works. Thank God for that. Right, let's get some background music. So, how do we start this off? So, I guess first of all, just give us the briefest introductions to yourself, Blueberry.
Right.
Put you on the spot. You know.
Well, I've been making demos for something like 30 years now.
Right.
Started on Amiga and have been diversifying into other platforms along the way. Um, I have this, what do you call it?
Fascination.
Yeah, fascination, but you could also call it kind of um, I can't help it, right? I have to put a compiler into everything.
As someone who's worked on some of the tools that you've done, it's always quite fun to see that why don't I just do this on hard mode and build my own programming language on the top of it, right? So why not? Why not? So the reason
Yeah, I
why
think that
go on, sorry.
yeah, I mean the nice thing about making your own programming language is that sometimes it happens that some other creative person falls in love with that language and does a lot of nice things with it.
This is true. Yeah, we're obviously alluding to Rose there. Um, let's just for a bit of background. Let's do the kind of boring kind of normal questions you'd get on some kind of podcast or whatever. So, what was your introduction to computing? What was your first computer? What's your first experiences with any machine of this technical nature?
Well, a friend of mine got a C64, and it came with this basic manual, and then just that realization that you could type in something and make the computer do stuff. That was just amazing.
Yeah, yeah. I
And
s-
that's where it all started.
Yeah, yeah. So I think mine was it was slightly adjacent. My dad was the one that brought all the tech in the house. It was what was ZX81, then a ZX Spectrum, and then eventually he realised how much I was. Well, he had to peel me away from the computer, so he got me a Commodore 64 in the end. So yeah, cool. The no CPU. I mean, I suppose the first question really is, where did the idea come from?
Yeah, so where did that the idea come from? I think some of the probably some of the sort of precursor ideas to this idea was that there's this. I've had this sense that many of the Amiga AGA demos that have been made throughout the years have been just the CPU writing to a chunky buffer, and then you C2P and show that, and basically you use the hardware just as some kind of primitive display device for showing those chunky pixels, and that's a big waste of all the amazing things that the Amiga hardware can do. And
Yeah,
I thought that for the Amiga 500, people are using the whole machine because you have to use the whole machine to do all these amazing things, right? And that hasn't happened very much for the Amiga 1200. So I was thinking, how do I actually make people use the hardware So one thing is, of course, you can make demos for just the vanilla and make it 1200. In some ways, it's a nice machine. In some ways, it's not. You know, the CPU is a bit hampered there, but then again, this is not about the CPU, right? It's about the chipset.
Yeah.
And it's been known for a long time that the chipset was Turing complete. So I got this idea a few years ago that it could be fun to have a compo where you were not allowed to use the CPU just to see what the chipset could do all of its own. Right? And there was this thread on Pruitt called Compo, where somebody was asking for ideas for new compos, and I sort of aired the idea there. But then in 2024, about 1.5 years ago, I got this idea that this could be a challenge, right? So instead of having a compo, I could make a demo this way and make it a challenge to say, okay, here's a kind of a proof of concept that this is something that can be done. And then maybe that would open people's eyes for a new way of making demos. And I mean, that was kind of one side of it. The other side was just that I'm very curious about what can actually be done this way. So I would like to see what other people come up with.
Cool.
And I realized that one way to do that would be to sort of make the whole setup, right? All the tools to be able to run demos like this. So kind of completely formalize how these things are run. Make a framework that people could use to produce demos like this, and publish the whole thing and make it a challenge, and then see what comes out of it.
Excellent. So just for our slightly less tech savvy viewers, when you say Turing complete, in layman's terms, what does that mean?
It basically means that all of the computations that you can do with the CPU, you can also do without the CPU. Maybe not as fast.
Or efficiently, or as easily.
Yeah, or definitely not as easily. But any computation, basically, that can be done without the CPU on an Amiga.
Yeah. So because I suppose if you consider a CPU, when you're adding two numbers together, that's effectively just it's just twiddling bits around, right? Which you could effectively do with the blitter if you know the right min terms and the rest of it. Then I mean it's not as easy as just writing an instruction to add one thing to another, but obviously the setup and stuff like that would be a bit tricky.
Yeah, you can add numbers with the blitter.
Yeah.
Definitely.
I was thinking about this earlier as well. Like a multiplication you could do, but you just have to do the same thing multiple times, right?
Either that, or you can make some tables and
of course.
that way.
Yeah.
It's common on platforms that don't have multiplication instructions to use various kinds of tables for to achieve multiplication. And you can do similar things on Amiga no CPU.
Cool. I'm trying to think now. So how? I mean, I get the idea, right? So I've looked at the framework. Obviously, the idea is that you basically have a data lump, and that has and the framework will effectively load that data lump into chip RAM. It will point the copper to the start of your data lump, or wherever that might be, and then it switches on the DMA, and then the CPU switches off. So I mean,
exactly. Yeah.
So I mean, in terms of I mean, I think maybe let's just start with the music. I know that wasn't necessarily the thing you worked on that much, but there's quite a few people that are trying to work out how you obviously turn a Pro Tracker replayer of any sort into something that works just via the copper. So
Yeah, so there's already many people here are probably familiar with the Lightspeed player.
yeah,
It's been quite popular by now by Leonard, and the way that one works and the reason it's so fast is that instead of interpreting the ProTracker module at runtime as the traditional ProTracker players do, it's actually compiling the module into it's a plain audio register writes in some way, right? It's like the way you play a ProTracker module in general on Amiga is that every frame there are some specific values you have to write to the audio registers to make it play whatever the module plays, and that computation of what to write to which registers in which frame you can do ahead of time instead of doing it at runtime.
so it's kind of like those AY register dumps that you get on like Atari and Spectrum and stuff. So you take out the computational heavy bit, and then you kind of end up with a data lump. It's never usually that simple, is it? But you know the principle's the same, isn't it? Make it dumb, but the data smart, isn't it?
Yeah. So we used the same principle in the No CPU Challenge demo. That it computes when it builds the demo. It reads in the module and it computes for every frame which values to write to the audio registers, and then it just creates a cover list that does that. So there's no real computation going on at runtime there. It just has a list, for every frame in the demo, which audio cover list does it need to call for that particular frame, and it calls that one. And that actually ended up being quite a lot smaller than we thought.
Right. Yeah, because I would have thought the
Yeah.
data you would have resulted it would have been quite large, but if you're deduping stuff, then
yes, we do the deduplication. There's a general deduplication mechanism in the framework, and that applies to the music cover lists too. So every case where the same thing happens in a different frame, it will reuse the same cover list.
right. Okay.
So it then ends up in, for the music in the demo, those music cover lists sum up to only 55 kilobytes, actually.
That's not bad, actually, considering that, a Pro Tracker pattern will cost you 1 kilobyte, and it won't last that long. So, yeah.
And then, of course, all the samples come on top of that.
So, I mean, so that's the music. I did speak to, I can't remember what his name was now, but I bumped into him on Mastodon, the guy who did the conversion part of it. Who also wrote
Slammer.
That's it, Slammer. I didn't realise that he wrote the original old school mod player plugin for Winamp, which I used for years. So,
yeah, he is. It turned out that he's done a lot of ProTracker related stuff in the past, so it was quite a nice coincidence that he had that experience and therefore could make that player. So
like kind of dropping away from the kind of technical details of it a bit. It seems like there's quite a few people that have kind of come out of the woodwork to kind of come together to create this production and also this crew. So can you tell us a bit about like how that formed and where that came from?
Yeah. So So the name Demostu from the Demostu All Stars refers to these private demoscene gatherings that Presence and his wife Castrellis have organized for the last, was it 6 years or something? Like 3 to 6 times a year usually. Where they've invited all of the demoscene friends to come over and for a weekend and just have fun watching demos and working on demos and just cozy cozy gatherings, right? And for these gatherings, in the beginning, it was mainly just people who knew each other and were already active, and then people get these ideas that we should also invite this person, and we should also invite this person, and so on. and that was how Slide and Slammer started to attend these meetings, right? Volker has been there for many of them, I think, but the fun thing is that none of these people I have not made any demos with any of these people before, right? All of these people are people that I have met through these Demostu gatherings. So big shout out to Presence and Castrellos here for bringing this team together. It's so amazing. So yeah, it's been so fun to build the team that way, right? And I've been maybe a bit pushy, you should also join in this no CPU project, and so yeah, I was very happy when I found out that Slammer was interested and had this very particular experience both with the Amiga hardware and the Pro Tracker format. So he fit right into the team, right? And Volker has been drawing this amazing graphics for the demo, and also been very involved in the whole concept development. I mean, this whole idea of these three girls that are rebelling against the evil CPU. That was his idea, right? And then Slide and CSJ also turned out to be a really, really good team, right? Working closely together on the music. So, and we all had a lot of fun doing it. It was amazing.
Excellent. It sounds like the perfect little melting pot for something like that, doesn't it? Yeah. I was finding, like, if you're in those, especially those little situations where you're a bit relaxed and you just be like-minded people, that stuff just happens, right? It's just
yeah.
I see. Yes, I haven't forgotten that I've been invited. I just need to work out when I can get there, right?
Yeah, it's some distance from the UK.
Yeah, but I like coming to Denmark. Denmark's always got the nicest passport control people. They smile at you as you enter the country, so which doesn't happen anywhere else. So, but yeah, I've got a strong affiliation with my lovely Danish people. So so yeah, in terms of the kind of how the rest of the demo works. No, I was thinking about. I was even just thinking about how would something like that work? Because you can't just. You can't. Usually, when you're doing a lot of stuff on, say, the A500, you're using code to generate copper lists. Because copper lists, as fantastic and as amazing and as dynamic they are, they can be a right pain in the ass to get right. Right?
Yeah.
There's especially that little bit at the NTSC line. That always bugs me. That. So.
Oh yeah, the line 256.
Yeah.
You don't avoid that this way. It's on the contrary, the copper has to stand on its own feet. So this thing is still a problem. Yeah.
So can you give us a bit of insight into like the tools and how, because obviously when you look at the demo, it's not just like, it's not just technically impressive. It's like, it's really well done. It's it's really well synced. If I understand, that's your dab hand as usual, because you're very good at that stuff, which is always good to see. But obviously, you're not just going to like manually handwrite copper lists to do that. There's obviously going to be some form of tooling above that to help. So can you kind of give us some insight into that kind of top level, how that stuff works?
Yes. So the basic structure of the demo is that you have a copper list per frame for the whole demo, right? So you kind of specify what should happen in every frame. And when you just do that, if you just say, oh, these are the complete copper lists I have for every frame in the demo, that becomes far too big, right?
Yeah.
Because these copper lists add up. So many of the copper lists are then modified. You have these self-modifying copper lists, right? Where the cover triggers the blitter to modify further down into the copper list, which might then be additional blitter instructions, which can then modify further down in the copper list and so on. So you can have these layers of self-modification, and that's kind of how most of the effects in the demo work. Apart from the effects which are just like pure blitter effects, like all of the transition effects, basically just the blitter. The cover isn't doing much there. The blitter tornado that you have in the background for the CPU and for the picture with the three girls. That's the cover doing a lot of blitz, but it's not the same every frame, but you have just 4 copper lists that you alternate between to do all the blitz. And the same with the game of life, it's also the same blitz repeated over and over again to do that. But the other effects, especially the checkerboard tunnel and the kaleidoscope effect, which is the background for the credits part, those are done with this self-modifying cover list technique. So that's kind of at the low level how these things work. In terms of tooling, I mean, you could go to your assembler and just write cover lists, right? But that would not really be feasible for the scale.
And it would also be horrible to do.
Yeah. So instead, all of this is, I mean, the whole memory dump is generated by a program in a high-level language. So for this project, I chose to write the demo in Dart, because that's a language that I'm intimately familiar with. Intimate in the sense that I've been working on the Dart compiler for several years. So yeah, there's a Dart program that has these more high-level abstractions for these different things. Like it has a concept of a cover list, and then the way the cover lists are put together is there's this interface in the code which is called the cover component. And a cover component is basically just something that can add instructions to a cover list, and that means that many of the things that happen, like a blit, for instance, is a cover component. A particular display setup for displaying bitmaps or sprites in a certain way is a cover component. So everything that happens is then phrased in terms of these cover components. And then these cover components can be combined, and they can call each other. Since the Amiga has 2 cover pointers, you can actually kind of do one level of subroutine calls between cover lists. So you can have call and return, and that is used heavily in the demo. And then, like, all of these cover lists turn into like basically just memory blocks with cover instructions in them, right? And you can have all the other data there, like bitmaps and sprites and samples and all the other different kinds of data you want to have there. All are these blocks of memory containing data. But these blocks, they need to have pointers to each other. So there's, in the framework, there's a built-in relocation system where on top of having data in the blocks, you can also have references to offsets into other blocks.
Right.
So you just set these, along the way. If you want to set a pointer in a cover list, you don't actually put the pointer values there. You just say, oh, this is a high word reference here and a low word reference. So the relocation system supports putting just parts of a pointer somewhere, because that's what you need when you set a pointer in a cover list. You need to set the high word and the low word separately, so the relocation system has to support that. And then the whole thing, when you have the whole thing set up, when you create all these blocks, it will traverse these references to see what are actually the blocks that should be included in the demo, right? Because you start from all the frame cover lists, and everything that is reachable from the frame cover list is the content of the demo, right? Everything that is not reachable, you can't point to that, so it's not there.
Yeah.
And then it does, as I mentioned earlier, then it has a deduplication pass where it finds blocks that have identical content and identical references and merges them together into the same block. There's a bit of a caveat there, because when you do modifications to blocks, then it things can go wrong if you deduplicate something and you modify one, but you didn't mean to modify the other one. Right? So there's a flag you can set on blocks to say this block is actually mutable, so it is going to be modified and therefore should not be deduplicated. And then there's a check whenever you do a blit that the destination goes to a mutable block, otherwise it will give an error. Right?
So there's a kind of finding those.
So there's some infrastructure there that makes this sort of all work together. And then all of these blocks are then allocated, they're put after each other in the memory image. But this is a kind of a final mechanism here that sometimes you want to just have a piece of memory to use for some temporary data along the way. So you can also have uninitialized blocks. And these uninitialized blocks, they can overlap each other, and they can overlap the data blocks as long as you don't use them at the same time. So in order to figure out what you can overlap, you need to know when things are used. And this is actually computed automatically from the frame cover list, because you know that every frame cover list is used in that particular frame. So it follows all the references. So when it looks at a particular block, it looks at what are all the frames where there's a path to that block. So what are all the frames that potentially use that particular block, and it takes the maximum and minimum of that, and that's the sort of the usage, the time range of that particular block, and then it can use that to overlap things that are not used at the same time. So there's a kind of a whole memory allocation dependency infrastructure.
Yeah,
that
that's
makes
good, but
the
it's
thing work.
one of those things. It's like it's worked out up front, so when the demo runs, it it's not asking the operating system for memory because the operating system's not there anymore. But it's just
It's all statically allocated. All the addresses are computed at build time, and then they are just put in as absolute addresses in the actual demo.
Yeah, because at that point it's like you've already worked out what you're going to need when and what doesn't overlap, so it doesn't matter at that point, does it? So yeah, cool. I wanted to actually just kind of touch on the Copper Showdown a little, because actually it was I remember actually it was GURP. It's the first time I bumped into you for a while actually. Mop did his presentation on the Copper Showdown tool, and I think both you and I had the kind of same initial thought about that tool. Was like, oh, that's like, I'm not sure if it's going to take off as like a shader showdown type thing, but actually as a tool for just understanding how the Amiga hardware works, and also just to be able to just sketch copper lists and stuff like that. I mean, I could really see the benefit there. What I found really funny is that it's actually turned into a no CPU tool now, right?
Yeah.
So
yeah, well, the funny there's a kind of a funny historic incident there that the Copper Showdown and the no CPU challenge, the ideas for those came about completely independently at almost exactly the same time, because it was like February, March 24, both of them, and sort of developed completely independently throughout 24, and then at GURP 25, Mop had his seminar, and I was speaking with him, also telling him about the no CPU challenge idea at that time, and it was fun that we had ideas that were so similar, right? And maybe the Copper Showdown also has a relocation system. It works a bit differently, but it's the same basic idea, right? That you can put in references to other blocks, and then those references are resolved as kind of as the final step before the whole thing is built, right?
So the executable that gets generated from the Copper Showdown, because there's been quite a few productions released from it now, hasn't there? I haven't got an exact count, but I mean, some of them, I look at them and go, how the hell have you done that with just the copper? But when you start getting into these layers of referential copper lists and pointers and blitters modifying stuff, then you start to understand, well, yeah, I mean, it makes sense. You can add numbers together, you can do anything, right? so does that mean that is the output from that a completely separate I mean, it's still the same principle, the CPU isn't doing anything when that runs, is it?
Right, yeah, it's exactly the same principle in that sense, yeah.
Wow. It's just the way it fires it up is slightly different, I guess.
Yeah, well, it's mostly the setting that's different, right? Where I had been thinking about this as something for making demos, like full-scale demos from the beginning, whereas the Copper Showdown is meant for live coding. I think one thing they also have in common is this idea of introducing people to the Amiga hardware without having to learn the CPU. Because that's something that both of these framework can do, right? And it's funny that this I mean, Copper Showdown has definitely had success on that front. I mean, there were several of the people that competed in the Copper Showdown at Evoke who had not really been doing anything on Amiga before. They just started looking into this tool and started learning about copper lists, and then they did stuff.
Yeah, because I think I ended up in the Discord. It's kind of nice to see people that don't really know the Amiga hardware doing stuff and going, oh, this it's a bit weird on the left-hand side when I do this, and then I'm just there going, well, I know why that is. It's because of this. So if you do that, and then what will happen is that will go away, and they go, oh, thanks, great. But yeah, it's just
and I
go on, yeah.
I don't think anyone has tried Copper Showdown and not complained about the line 256.
Oh, I hate it. I hate it with a passion. Oh, God, yeah. Cool. Where are we doing for time? So we're not bad, not bad. What I will do is let's have a quick break.
But yeah, to sort of connect these things together.
Oh, yeah,
I've been in sort of in contact with Mob throughout the process. Also, in order to you could say align these projects with each other, and sort of the upshot of that is that you can actually use Copper Showdown, the Copper Showdown editor, to create a demo for the No CPU challenge. I mean, if you just export it from there, at least with the raw chip memory image exporter that is upcoming in the Copper Showdown, if you just export the image, then it will be compatible with the No CPU challenge.
Oh,
so
right.
we can use it as a tool for that.
Cool. So yeah, so there you go, chaps. You've got no excuse not to compete for the No CPU challenge. You now have high-level tools to go and make demos, Amiga demos, without having to touch a single piece of 68,000 assembly language. There you go. I think at this point, just because obviously the poor people in chat have been greatly ignored because I've got a friend round. So I wanted to. I haven't seen anything. So if you have asked any questions, I haven't seen anything. Does anyone have any questions from the chat for our chap Blueberry? I'm sure you do. And the problem with when you do this on Stream Blueberries is you ask the question and then it takes another 30 seconds to a minute before they start coming through. So, so you have to kind of fill this space. So that was definitely the only barrier. Oh, I know that's in response to something that Photon said. So, so we'll let them. We'll see if anything pops through. Why did you release such a brilliant demo already? Demotivating. It's demotivating everyone to take part in the challenge. Well, that's. I mean, look, it's Blueberry's fault. He's got a dab hand at this stuff, and when you give him some good graphic artists and a good musician, then yeah, he's gonna just tighten those edges up and present it really nicely. So I mean, what's your answer then, Blueberry?
Yeah, well, it's a bit of a balance, and I had considerations of where should we target this, like how much should it be just a proof of concept and how much should it be a nice demo. I think that if I'm to sort of give an excuse for doing it this way, it would be that the complete source code is available, right? So you can so it's a kind of a demonstration of here's a way to do it, and you can go and see exactly how it's done, and then it's your turn to develop that idea further, right? So the idea from the start has been, as I said, that I would like to see what kind of ideas could come out of this, and I think, this is just one way of making such a demo, by having the one copy list per frame and so on. There was this Interceptor intro from Revision that did this in a completely different way by having this abstract machine that is interpreted by the glitter So there are a lot of different ways to do this, and I mean, you can take my framework and use it to make a demo, or you can use it for inspiration and do something yourself. And um,
Yeah,
I think,
I'd like to see something really super avant-garde with like some random modifying copper lists that generate some kind of noise demo, but it's somehow it just orchestrated just right. I don't know. So I've been picking up the other questions. Neversoft asked, "What's next?" So I don't know
um,
what's next. I guess you must be working on something for GURP. If you've set the challenge, you can't just not throw your hat in the ring after that, can you?
well, that's a good question, actually. I To be honest, I don't really know yet what I will be bringing to the GURP compo. Yeah, just to maybe recap, maybe it wasn't clear from the discussion. So this demo is an invitation for like the next step in the challenge is the no CPU compo at GURP 2026, which is at the end of January. Um, and no, I actually don't know what I will be making for that compo. So it's the main idea of the challenge is actually not to compete against whatever other people would bring to that compo, but mainly to have the compo and see
You're
what
just the fire starter in the
comes in
situation,
it.
right? Yeah,
Yeah,
just
yeah, exactly. I mean,
yeah, yeah.
as maybe I mean, I can actually turn the previous question around, right? Clayton asked why why make such a nice demo to begin with? So I'm demotivating people to make something for the for the actual challenge.
Yeah.
So you could turn that around and say, well, now I made the nice demo, so I don't have to make something nice for the challenge. So
Yeah,
that's for you to do. Right?
yeah, yeah,
Uh,
yeah.
um,
I've always thought
and
I've always thought this as well. Like, there's been times where I was thinking, well, I tell you what would be really fun. Why don't we make a one pattern compo, like a track to music compo, where you're only allowed to use one pattern? And then I think, well, if I do that and I set up the competition and then I enter it, everyone's gonna be like, well, you had this ready, didn't you? It's like, well,
yeah,
I just
yeah,
thought it'd be fun.
that's
Yeah,
kind of how it was with the checkerboard challenge, right? Uh, and with Slummy's rubber challenge for that matter. I mean, we had ideas or to begin with on how we wanted to make this for for the actual challenge. Um, it's not the case for this one.
No, I think that's a nice. It's a nice introduction. I think it'd be fun to see what other people come up with for this. And I think the fact that the Copper Showdown editor is literally it's a way in to that competition, right? Which means people can. That's one thing I haven't checked actually. Can it import a Pro Tracker module yet, or is that not? It'd be,
Not the cover showdown, no.
it seems like it needs
Savior
to.
made his own. What?
I said it seems
Yeah,
like it
yeah. So
needs to.
Savior made his own converter that could convert into something that he then used in Copper Showdown. I don't know if that one is public.
Right.
I mean, so there is, for doing that kind of conversion, there is the Lightspeed player, and there's also the converter in the no CPU framework
Oh right. So
for the no
so
CPU
the
challenge demo.
the converter that you used for your demo is publicly. I mean that's the sensible thing to do.
Yes,
That's what obviously,
yes.
but it's there. You can chuck it a Pro Tracker module and you get all the data that you need.
Yeah, exactly. And it is quite clear that music is probably the biggest barrier to entry for things like this, right?
Yeah.
I mean, it's not, you cannot expect everyone to sit down and write their own Pro Tracker player.
No.
So, so yeah, use the even if you don't use the framework as a whole, you can definitely use the player, the converter, because that generates cover lists, and you can take the code that generates the cover lists, and if you want to make your own framework for the challenge, you can definitely take those cover lists and then include them in your own demo. It should be pretty easy.
So JC1980 asked, were you inspired at all by architectures such as Cell with this sort of demo?
No, not really. I mean, in a way, I mean, many PC demos and especially PC 4Ks don't use the CPU very much either, right? Except for music, and some don't even use it for music. It just needs to kind of be there to start up the actual thing that happens. So I think
it's the same thing. It's the same thing, isn't it? It's like the shader is the copper
kind
list,
of
right?
the same thing, right? Yeah, exactly right. It's the GPU. It's just a pure GPU demo, right?
Yeah.
So the difference is that the GPU in a typical PC cannot run itself, or actually it to a larger degree it actually can. So I think it's with the latest features like work graphs and stuff, you can almost have just the CPU start up the GPU and then the GPU just continue on from there. I think you need to involve the CPU for swapping the frames or something, but it's getting there. So I think that's kind of a parallel, but
Rebel.
But no, it was more like just to see what the chipset can do on it.
Yeah. Rebel from Cortex said, "Did you use any hardware sprites in the demo anywhere?"
Yeah, lots. There's the very nice thing about sprites on AGA is that because the sprites are 64 pixels wide, you can actually cover the whole screen with sprites. So most of the times in the demo where you see these transitions sort of covering the screen or the wipe in and wipe out of all these different transitions, most of the times in the demo that's actually just a layer of sprites on top of the effect. Not all of them, but most of them. Also in many of the text parts, the text is sprites. In the credits part, the background effect is actually running in sprites. So the kaleidoscope effect, if you look at it, it's only 64 pixels wide, and then it's repeated 5 times throughout the screen, right? So that is actually done by rendering just one sprite, and then setting the sprite pointers for all of the sprites to the same memory. So all of the 5 sprites read the same memory. So it only has to be rendered once. And then the QR code at the end is also a sprite. So lots and lots of sprites.
I think that's probably the most amount of AGA sprites used in an AGA demo for a very long time, isn't it?
Probably,
yeah.
And the most diverse use of them as well.
Yeah, really good. Photon has asked, will the no CPU competition accept equivalent entries not made with the framework, i.e. what are the rules? I think that's just as long as your demo doesn't necessarily need to be made by any framework. It's the demo is effectively just your data lump, isn't it? So yes.
So you don't have to use the framework to make the demo. The only sort of requirement is that the data, the memory chip memory image that you supply has to be compatible with the this runner application that is included in the challenge repository, and but that basically just means they know that there's some specific initial register values, and the cover list starts from address 0, and I mean, it shouldn't there shouldn't be any hindrance to making it compatible with that runner, or if there is, I'd definitely like to hear about it. But because it's definitely the intent of the challenge that that it should be completely general, like everything that you can do without the CPU should be doable in this particular challenge setup.
So yeah, that's what I found quite interesting, because I think I looked at the when you released the framework, I had a quick look at the code, and it's one of those where it's like it fits on a page almost, right? There's not much to it. It's just like it loads a file, it uncompresses it, it sets up some registers, and it points and kicks off, and then that's it. So in terms of that, it is super simple. So, oh, hang on. Is there a direction, Neversoft asks, is there a direction somebody could take this where you think, wow, you're a freak, how far could you push this? I think that's what Blueberry was after all along, really.
That's definitely the intent. I mean, this is not meant as a one-off thing, right? I mean, hopefully I can convince the GURP organizers to have this compo every year for the next many years, and then we'll see how this thing evolves over time. Because now it's still a very new thing. It's a new platform, right? And I think as time goes by and as people get inspired by each other's techniques, we will see more and more sophisticated things being made with this. So that's definitely my hope for this, that this is something that will grow and
can it evolve
and sort of have its own life over the years. Like we see on many other platforms that the effects and the techniques get more and more sophisticated over the years. I think we could see something similar for this. That's what I hope.
Yeah, it's kind of the thing I see. We especially get to things like the Copper Showdown tool, and you end up with a Discord and then like a little community around that. What you tend to find is that the element of sharing, which is something that you've been a real big proponent of, right? So you create a synth, you use it in a couple of demos, and you give it to everyone else. Going, well, there you go, I've made this thing. Why don't you use it? Like the Rose engine, like I picked that up and I made a bunch of demos with it. Had a lot of fun with that. But it's that sharing, and it has to be said that the demo scene in its earlier years wasn't particularly very good at that. That whole sharing, like, oh, I've worked out how to do this thing. Why don't you have a look at it? And it's when that happens, it's then someone else picks up and goes, oh, well, hang on, how about if we do it this way instead? And then twists it up in a completely different way. So
there was I got a question from Xavier, whether the competition will be separated into OCS and AGA competitions, and that is not the plan. It's a single competition for all Amigas, similarly to how it is with the other GURP competitions, and also what you typically have at revision. So it's you can use whatever chipset you want for the no CPU compo, and it's the same compo for everybody.
Cool. So I mean, yeah, it feels like AGA kind of feels like a bit more of a level playing field at that point, if you get what I mean. But I know there is, there's remarkable, marked differences
Yeah.
between the chipsets, in terms of the amount of colors you can have and the size of the sprites and stuff. But
Yeah.
when you take away,
There's definitely, yeah, they're definitely closer to each other in power than Amiga 500 and then AGA with those 60, which I know 60 is 100 times faster than the 68,000, right? So
yeah.
so there's a huge difference there in practice. Whereas with the no CPU setup, the copper is the same, the blitter is the same, so all of these basic units, the computations that you can do are basically the same. It's just on AGA. You get a few things on AGA. Of course, you get more memory, the wider sprites, more colors.
Do you get
less DMA load from the bitplane DMA?
Yeah, because doesn't that, if you were to use a lower bit plane on AGA, you end up with a bit more DMA time if you put it in burst mode? Is that right? I can never quite remember. I haven't coded that much in AGA, so.
Yeah, well, when you set the 64-bit fetch mode on AGA, you only have, it reads 64 bits at a time, and it only uses one bus DMA slot per bit plane for that, instead of one for each 16 bits. So you get much less load from the bitplane DMA that way. So that makes a difference in terms of how many cycles are available to the copper and the blitter.
Right, so you do get a bit of...
In that sense, you could say there's a speed difference. Well.
Yeah. You'll get a bit of uplift in DMA time in those instances. But then obviously if you put it as a 256 colour display, then you're going to hamper that anyway, aren't you? So...
Yeah. To some extent. It's still less, but
Yeah.
Yeah. But the runner supports this kind of fake chip mode for Amiga 500 with ECS. So you have 1 megabyte of chip memory.
Because I remember this. There's if you've got slow RAM on certain chipsets, even without doing the chip RAM modification, you can just point the pointers up at what is it, 8,000, whatever it is, 80,000, and it just works.
Yeah, exactly.
Yeah,
it just works. That's quite incredible. It's quite incredible that so few people have known about this for so many years. But yeah, you can on the GURB compo machine, the GURB Amiga 500 compo machine has ECS Agnes, which means for the no CPU compo, it will support 1 megabyte of chip memory.
Right. Yeah. So I have to double check. I think my 500 is an OCS Agnes. I'll have to double check. It's definitely the one with the broken Sprite 6. I know that much, but I don't know whether it can do the 1 mega chip RAM. Yeah, that's not fun when you find that. And you really need that sprite, I can tell you.
Yeah, so the difference in memory between OCS and AGA for that setup is also, it's not half a megabyte versus 2, it's 1 versus 2.
It's one versus 2, yeah. Excellent. So I think unless there's any more questions, chaps, we'll fire the question over to the chat and then see if anything pops up. I'm sure something will. Let me just check. I've got everything there. Oh, I forgot. Annie7 said, "Is there a dream collab you'd love to do, Blueberry?"
I think there are several. I mean, I like to especially to collaborate with new musicians. So I mean, I've been doing stuff with loads of different musicians over the years. But generally, I mean, it is always fun to work with new people. Um, yeah, I have. I don't know. I've been thinking of maybe doing something with Yogi at some point. I mean, I've been now I've actually met him. Like you know, 30 years ago, I listened to a lot of his music, and he was kind of a legend back then, right? And now he's just this guy that I've been talking to at demo parties. That's how things work out sometimes. So yeah, maybe. But you know, definitely, if you think it would be fun to do something, by all means, reach out. I
Yeah,
mean,
yeah.
I'm
That's. I
open
mean, that's.
to.
I think that's the important thing,
Yeah.
is because I mean the a lot of I mean our collaboration was you just emailed me and went I've got this synth, we're doing something for a boot block. How do you fancy it? Oh, well, yeah, okay, I'll give that a pop. That looks like fun. I'll meet you at Data Storm. But it's always that if you just was that it?
I can maybe I want to answer the question in a different way. I could say, you mean the kind of collaboration that I really love is where I make tools and somebody else uses them.
That is good, yeah, yeah. And when they break them, and there's a deadline looming, and then they send you a very stressed email, right? Those ones, yeah.
That's part of the fun.
Yeah, yeah, it's all part of the fun. I had a question here from Volker Blueberry. Why do we all, in brackets, keep making things for these ancient platforms? It doesn't make any sense. I know it's not just the challenge. What else is in it for you? It's a brilliant question. Yeah, because I find myself spending every waking hour of my life coding away at something for a machine that's 30, 40 years obsolete, and I wonder why.
Yeah, yeah. Why? I think somehow I think I'm kind of hooked. You know, I have been exploring various platforms and also been doing some PC stuff, um, I keep returning to Amiga. It's always you know there's something special about the place where you started, right?
Yeah, yeah.
It's a comfort zone of a sort. And then you know extending it and coming up with new ways of doing things like this, you know, CPU stuff, and I think it's a lot of fun to make and use high level tools to do things for these old platforms.
Yeah, yeah. I mean,
It's also fun to just sit in SM1 and do something, right? It's a different kind of fun, you know. I like to do both.
Yeah, yeah. I mean, you know, the whole tooling thing was the biggest lesson I ever learned. Was because I mean, some of the first few things I did when I got back into the scene back in 2010, I was basically writing tools in DevPack. Using WinUAE because I had no idea how to use any of the high level languages. All I had was assembler, and didn't really learn anything else. But yeah, I think the thing for me is you know, is making these old machines do things that people might not otherwise believe that they can do. So and it's just making an old machine flex, whether it's a Mega Drive, C64, a ZX Spectrum, a ZX Spectrum beeper, anything. You know, it's the learning of how another system works. How does that system work? How does it fit together? What can I do with it? How you know? And I think that's the really. I mean, for me, that's just the fun part of it. So. Do we have any more questions? Have I missed any? I probably have. Let's have a quick check. I should have like created. And see, if I was a professional, I would have like created some special redeem that you could use that would highlight it and log these things somewhere. But you know, we don't do things properly around here, do we? So.
Oh yeah, I see that Platon has noticed that we used a lot of color cycling in the demo. That's just kind of an obvious effect in this setting, right?
Yeah, yeah.
And yes, the part where the rebels are presented, the background effects there is color cycling, and it's basically just the color cycling is made in Deluxe Paint. I mean, Volker made the actual effect that you see there using color cycling in Deluxe Paint, and then we imported the color cycling data from the IFF file and had code to show that in the demo.
Yeah. So if there's no more questions, I think we can let you go, Blueberry.
Oh, there's a question here.
Oh, is there?
Yeah, from NE7 says, Blueberry, what sort of things completely outside of demos of tech inspire you?
Oh, that's a great question.
Yeah,
It's a great question.
I think being outside in nature, walking and seeing, all of the colors and shapes and sounds and movements and everything, all of these things that I see in nature. There are lots of these things that inspire me. I often get demo-ish ideas from walking in nature. So I think that would be my sort of immediate answer to that question.
Yeah, I mean, all you have to do is look at the veins on a leaf to see the procedurally generated cells. Excellent. So if there is, we'll give them a few more minutes in case there is another question. And if you have asked a question, please ask it again because I've missed it if we've not answered it. But yeah. There we go. I think they've run out of questions. Yeah, walking is the best writer's block solution for me. Yeah. Excellent. Well, unless there's anything you want to chat about, Blueberry. I mean, we have touched on Rose, but it's one of those. I don't think I can make another Rose demo now. I'm not allowed to. I don't think. I want someone else to try it because I think. Yeah. Actually, this is from me to you. If you're not going to do the Copper Showdown, do a Rose demo. And if you're not sure what to do, come and speak to me because I love that language. And I think it is a brilliant language for creating, although simplistic looking effects, like super highly synchronized effects. Yeah, it's a lovely system. You should definitely play with it. Everyone should have a go. Everyone should have a go with Rose. It's dead easy. So, yeah. That's...
Yeah, as long as you are comfortable expressing everything through recursion.
Yeah. I mean, you get used to it quite quickly. It's one of those things. You get used to it quite quickly. So yeah. All right. Well, I think that'll wrap us up nicely, Blueberry. Thank you so much for spending the time to chat to us today. It's been brilliant. I mean, obviously,
thank you for having me.
This no CPU thing is just the tip of the iceberg for what this gentleman has done for the scene and within the scene and around the scene. If you follow that all the way down, you will see a plethora of fantastic things. I mean, there's Rose, there's Sinter, there's the other two synths, like Oidus, and the other one I can't remember the additive one that you made. I can never remember the name of it. There's Nexus 8, the 8 kilobyte version of Nexus 7, which is an AGA Amiga demo. in 8K. I mean, just go and just everyone. Shrinkler, yeah, which has been the saviour of all 64K and 4K Amiga demos ever since. Just yeah, we can only thank Blueberry for these fantastic bits and pieces. Is there anything you'd like to? I mean, usually these points you'd probably say, "Oh, do you want to promote your thing or whatever?" But I don't, unless there's the thing you want to promote is the no CPU thing more than anything else, I imagine.
It's mostly that one, yeah.
Yeah.
Now, when you speak about synths, my current synth project is the one called Jingler.
Oh yeah.
With all the other ones, which has been standing still for a few years, but I'm picking it up again, and I'm hoping that is going to become something that is very useful for PC, 4K, and 8K intros.
Excellent.
Hopefully something that will appeal to musicians to a greater degree than forklaying. That's the idea.
It's one of those,
it's not there yet. It's currently text based, so I won't claim that particularly appeals to musicians. But the plan is to have some kind of nice interface.
I tell you who it does appeal to is those kind of musicians that are also programmers. So yeah, we'll have to. I'll have to. I've been meaning to have a play with that for ages. Someone did mention something. Hang on a second. Where was it? Neversoft has got the most important question of all, and I mean, you would have had to have been on the stream to really understand this, but does Blueberry know what the 5th channel of Imploder does? We'll do.
I don't think so. I mean, I have been. I do remember, looking at it and thinking, what's that thing doing? But no, I don't know what it does.
No. So it's basically a meme around these parts now. Where whenever we've got the Be Right Back that you saw earlier when we were doing our testing, is the Imploder music, and at some point, I think it's usually Minimo from Spreadpoint will post a. Those like Chuck Norris facts. It's kind of one of those, but like for the 5th channel of Imploder. Like, the 5th channel of Imploder was known to sign the Treaty of Versailles, or But Minimo has actually disassembled it and can tell you exactly why. But let's leave it as a mystery. I think that's the best way. So I think that's it. If Chuck Norris wrote mods with 5 channels, yeah, exactly. Thanks, Subby. Anyway. Thank you so much, Blueberry, for coming on. It's been an absolute pleasure. We're going to do a BRB, and I'll be back, and we'll. There is a little something that I've got for you lot that you couldn't hear, but let's keep that between you and me, all right? But we're going to do a BRB. Anyway, everyone in chat, give them a big round of applause, a big clap, a demoscene clap to our lovely guest, Blueberry. And it's lovely to see you, mate, and take care. And I'll be back in a bit.